Okay, good day to each and every one of you. This will be the first and the second sample problems for shear stress and bearing stress. Since we already discussed all about the concepts of shear stress and bearing stress, then let's move on with a brief sample problems that we have here. Okay, so for this problem, we have here two metal plates that are stacked on each other. This is the top view of the plate, and this one is the side view of the plate. Then there are almost about three rivets that fixes the interaction between the top and the bottom plates. And the problem wants us to simply solve. For the first problem is that the corresponding shear and bearing stress, and of course the average tensile stress for each plate, the upper and the bottom ones. So for problem number one, okay, for problem number one, simply solve for uh, tensile stress, the bearing stress, and the average tensile stress for each plate. So this is just a straightforward approach in solving this problem. So let's start with problem number one. So this is fairly easy, and this would be the requires for sample problem number one. Solution. The solution for solving the shear stress, that is simply V over A, or the shear force divided by the cross-sectional area. So that should be T, or Greek letter tau. And the shear force, V, is the given for this P, first and foremost, is 50 kilonewtons. Okay, that's 50 kilonewtons for P going to the left and also going to the right. We have the length of the plate equivalent to 130 millimeters and a thickness equivalent to 25 millimeters, and the diameter, of course, of the rivets is equals to 20 millimeters. And P for problem number one is equivalent to 50 kilonewtons. So we can simply assume that if P is acting on to the left and then to the right, as you can see here on the side view of our free body diagram, so the one resisting that shear force is the, or rather the rivets. Okay, since we have three, then this is a what you call a triple shear, but the problem stated that the force is evenly or somewhat equally distributed through these three rivets. So means to say that P is equals to V. Okay, solving for that one, this is triple shear because we have three rivets. That should be V over 3A, because it's triple shear. So tau is equals to 50 kilonewtons. Okay, that's 50,000 newtons divided by 3. And then the area, which is the rivet, we have a given diameter. That should be 3 multiplied by pi. And then diameter, you convert it into meters, 0.02 meters squared divided by 4. Okay, so solving for shear stress, so tau is equals to approximately 53.05 megapascals. And the next one is for us to solve the bearing stress generated. Okay, so bearing stress is simply P sub B over A sub B. This one is the bearing force, which is equal to 50 kilonewtons, and A sub B is the wall of the hole generated in our metal plates. So that should be sigma sub B is equals to 50,000 newtons divided by, what is the thickness of this plate? We have 25 millimeters, and we have, of course, the diameter of the rivet equivalent to 20 millimeters. And don't forget, we have three rivets, so this is again over 3. Okay. And the thickness of the plate is 0.025. If you're going to convert it into meters, 0.025 meters multiplied by the thickness of, or rather the diameter of the rivet. So that should be 0.02 meters. Okay. So solving, sigma sub b, or the bearing stress, is equivalent to approximately 33.33 megapascals. So 33.33 megapascals. Okay, so we managed to solve for the shear stress and the bearing stress. And the last one for problem number 1 is for us to solve the average tensile stress for each plate. So that should be sigma sub t for tensile. Means to say that we need the shear, or rather the axial force, P sub t, divided by the area of influence. But for this required, we already know what is P, which is 50 kilonewtons, or 50,000 newtons. And the problem we need to determine here is what would be the corresponding area. So this is 50,000 newtons divided by what is A sub t. That is simply, let's try to draw it on a isometric view. This is the metal plate. This is the metal plate going like this. We have here the thickness. That is the thickness. We have the length given. That was based on the problem. The length of the plate was 130 millimeters. So this is 130 millimeters. We have the thickness equivalent to 25 millimeters. We have here the rivets 1, 2, and 3. And the problem was also solve what is this sigma sub t, or the average tensile stress. So means to say, if that is a tensile stress, that should be acting perpendicular to our cross-sectional area. So what would be that cross-sectional area? Obviously would be this one. Okay, this would be our area of influence, or you can say that it can be somewhat found at this portion going like this. Okay, like that. This would be the area of influence, or you can also say it here. Huh? It's the area of influence. As long as it is acting perpendicular to our cross-sectional area for sigma sub t, or the average tensile stress, that should be acting perpendicular. Okay, that should be P sub t, or this 50,000 newtons. So in order for us to solve for sigma sub t, we need to consider what should be the area of influence. So that should be this one. But we have a rivet. Now we have 3 rivets, but the problem states that the force is evenly distributed throughout the 3 rivets. Means to say that we need to subtract the length of this plate with the diameter of the rivet. Okay, so this is a rectangular shape, so that should be 0.025, which is the thickness is 0.025 multiplied by the length of the plate, which is 130 millimeters, or 0.130 minus the diameter of the rivet, which is 0.02. Okay. So solving for sigma sub t, that should be equal to approximately 18.18 megapascals. So that would be the solution for our problem number 1 for shear and bearing stresses.